Okay, now let's solve that same differential equation with the unit step function in there using Sage. And so let me get rid of this. Okay, so I have the variable t. I have those same initial conditions. I actually just copied this right out of the Laplace transform one. Here I define the differential equation, but notice it's 0 because from 0 to 3 this differential equation had a right-hand side of 0. And so here I called it solution from 0 to 3, and I just use dsolve, and so I take that differential equation, the variable, the dependent variable is x, and we have these initial conditions, 0 for the t value and so forth, and so then I go ahead and evaluate that and see the answer, and that looks familiar. So that looks great. So then what we need to do is get the new initial conditions, and so that's where I had this. Was I said, well, x0, my new x0, or initial value x, is going to be that solution up here, solution from 0 to 3, with t equal 3 in it. And then I show that to make sure everything's working okay. And then x prime, well, I take that solution up there, I take the first derivative of it, so diff1, and substitute in t equal 3 to that and show that. I'll hit evaluate. And those look familiar as well. 7/10 e to the 9 plus 3/10 e to the negative 21, and the 21 over 10 and the minus 21 over 10 and so forth. Okay, so I found out what those constants were there, and now I am ready to redefine that differential equation because the right hand side changes, and then solve it again. But I'm going to make a couple of changes, so I put that in here, and so differential equation again, but this time it's 1, and now I have I don't start at 0 anymore. Now I'm starting at 3, but I've already changed my initial values for the function and the derivative, so that's good. Now here I'm just going to call it SOL3 for 3 or higher, and I could change my comment on here, so t greater than or equal to 3, something like that. And I could put comments for the substitutions I'm doing there, but I think that's it. And so let's evaluate that, see if it works. I haven't tried it yet, so we'll see. And look at that. That looks pretty familiar. Not totally, I don't remember for sure, but I do remember there were the 2e to the negative 7t terms, one constant and then one involving the e to the 21. Yeah, so this all looks good, and then minus the 21 for that particular solution we had, and there you go. So I used the techniques, although dsolve doesn't show me I'm using those techniques, but I used the techniques of chapter 4 to solve each of these two differential equations, but I had to update the initial conditions when I got to 3. And all it took was a couple of commands here to do those calculations. And there you go. That is the Sage equivalent of what took me like 25 minutes to do by hand. I kind of like the Sage. It's nice that way. But you want to know how to do these things by hand. You just something like this. When you start getting constants that are as nasty as this and so forth, yeah, there's a real good chance I'm going to make a mistake. And so, doing it within Sage and having it do the I'll call it mindless calculation. That's not really true. I have to think really hard when I'm doing those calculations, and that's the problem. Because to think really hard, and I still make mistakes at times. So it's kind of nice to put that calculation part, all that old algebra, into Sage and let it do it, but I can tell it what steps need to be done. And so there we have our final solution there. And there you go. That's good for that video.